So, we did a few problems already. We'll do a few more examples just to make sure that we really have this normal distribution stuff down, because you will see problems on the normal distribution next week on the exam. Okay. So here, let's try another problem. Let's say we're going to look at a bunch of let's say babies. Okay, babies born full term. Not premature babies. So babies born full term, on average, does anyone know the average weight of a baby?
7 pounds.
Around 7 pounds. Okay, so we'll just keep it simple. Okay, we'll say have mean weight of about 7 pounds. Okay, that's the average for babies born full term, and the standard deviation is let's keep this simple, and we'll say is 0.6 pounds. Okay. The mean weight is 7 pounds, and the standard deviation is 0.6 pounds. All right. So I'm going to say what percentage of babies babies born full term weigh less than 8 pounds, and what percentage of babies weigh less than we'll say 6.5 pounds. And then one more. What percent of babies weigh between 6.5 pounds and 8 pounds? Okay. Go ahead and try to solve those problems. table, you're gonna need that. So I don't think you finished parts A and B yet. Okay. You're gonna, for the last part, you're gonna take the difference between A and B. All right. I know some of you guys are still working, but let's take a look. All right, what do we have for part A? What number do we get there? 0.95. So 0.9525, right? So this, huh? So the average weight is 7, and if I go to 8 pounds, how much is shaded over here? 0.9525. Is that good?
Yeah.
Okay. What about this one? At 6.5. 0.2033, right? So here I am at 7, and I'm going over here to 6.5. And the area over here is 0.2033. Yes?
Because you asked what percent, is it correct if I write
Okay, yeah,
it?
20.33, sorry. Percent proportion, it's all the same, okay. So 0.2033 or 20.33%. We having problems with either of these numbers yet?
No.
Yes, question.
Just my question on the test, would it be rounded off or would it be like, would it be 20%?
Yeah, I would leave all 4 decimals there, okay? Alright, so the last part says what percent of babies weigh between 6.5 pounds and 8 pounds, okay? So what I'm going to say, what I'm looking for is here's 7 and here's 6.5, and I'm asking what percent's in between 8 and 6.5, okay? So I'm asking for this part here, okay? So to get that, I'm going to take this entire area, this 95%, and subtract off this portion. And by doing that, I'm going to be left with the part that's in between. Does that make sense? So if I've got basically about 95% is less than 8, and about 20% is less than 6.5, I'm going to have about 75% between 6.5 and 8. Okay? So my final answer for this third one is 0.9525 minus 0.2033, and I get 0.7492. Thank you. Yes.
For the second one, I got -2.
Okay, so your z-score is negative, that's correct, okay? But remember, this represents the area, okay? So when you look up negative 0.833, the area in the table is positive 0.2033. So you never turn the area numbers into a negative, okay? Because it doesn't make sense to have a negative area, okay? So just leave it as 0.2033. You're right, you are looking up a negative z-score, but the area is 0.2033. Okay, is that all right?
Yes.
Okay. What if I change things around? Okay. All right, and we're gonna say let's say the hospital has special services for the smallest 5% of babies, okay? Or let's say smallest 4% of babies, okay? Or the lightest 4% of babies. So, what is the weight? At what weight do they consider a baby to be eligible for the special services? Does this make sense?
Yeah.
At what weight that. This one's a little bit tougher. Alright, well, this one's a little bit different, so maybe I'll guide you guys through it. Alright, what are we looking for? The weight of the baby. Okay. Now, what percentage of babies weigh less than this particular baby?
Not one
Okay. So I'm looking for a particular weight. Okay. Whatever this weight is, what percentage of babies weigh less than this weight?
4%.
4%. Okay. That's what this problem is saying. Okay. So at some weight, okay, some unknown weight, we're gonna have, how much is shaded over here? 4%. So 0.04 is shaded. Okay. But I don't know what this weight is. Okay. Well, I do know for a fact what?
7%. Average baby weighs 7.
I do know that this number has to be less than 7 pounds, right? Okay. So, what is the z-score that's going to give me 4%?
1.75.
Yeah.
Negative 1.75.
Yeah, the z-score that's going to give me 4% in the area is z is equal to negative 1.75. I want to make sure we understand where we're getting negative 1.75. Yes?
Did you get the 7 from that information? Like the problem of
Oh yeah, the previous problem. So
Okay.
it's the same, continuing on with the same mean and standard deviation.
What is that other number then?
What other number?
Before the 7?
Oh, this is a question mark.
Okay.
It's an unknown number, right? Unknown. Question. Okay. So can we see that we have z equals negative 1.75?
Yeah.
That's going to give me that's the spot where 4% of babies weigh less than z equals negative 1.75. Yeah, a minute.
How did you get to 1.75?
How did I get negative 1.75? Okay, so what I'm doing is I'm looking in the table and I'm asking which z-score is going to give me an area to the left of 4% or something very close to 4%. And what's that z? Negative 1.75. When I look up z equals negative 1.75, I get the area is 0.0401. Okay, so you got to look through this entire thing for a number that's close to 4%. It feels like a lot, but all the numbers are in order, so it's not too bad. Okay?
So we can do like subtract this 0.4 from the mean to get.
No, I'm not subtracting anything from the mean yet. Okay? I'm looking for which z gives me 4%. And what is that z? It's negative 1.75.
Oh,
All these numbers are basically percent.
All the numbers here, this is percentage that's shaded in this under the curve.
So you have to look through the chart.
Yeah, you gotta look through the chart. Okay.
You look for 0.4? Or I mean
You,
0.04?
0.04. 0.04. The number that gives you 0.04. That's negative 1.75. Okay?
So we look on the negative side.
So the number that gives me, the z that gives me 0.04, or the closest number to 0.04, so 0.0400 in the table. Okay? So I don't look up 0.04. I'm looking for the number that gives me 0.04. Okay? That's very important that we understand that.
Okay, so
Yes.
we go to 0.04 at the very top.
No, no. We're looking, so there's a whole bunch of numbers here, right? Okay? I'm looking which number is closest to 0.04. It's around right in the middle, okay? So there's a whole bunch of numbers, and I'm looking for the number that's the closest to 0.04. The number that's closest to 0.04 that I can find is 0.0401.
Okay.
Okay? Now what is the z-score that gives me 0.0401? Negative 1.75. It's in the row negative 1.7 and the column 0.05.
Okay.
So I choose negative 1.75.
You just have to look.
You have to look. You just have to look. That's what I'm trying to tell you. Okay. So now that I have z equals negative 1.75, what is the weight that's going to give me a z of negative 1.75? 5.95. Now, how did I get that? Well, I know z is equal to whatever my weight is, x minus the mean over the standard deviation, right?
You just plug in.
So my z is negative 1.75. My x is what I'm looking for. My mean is 7, and my standard deviation is 0.6. So I get negative 1.05 is equal to x minus 7, and then I get x is equal to 5.95.
That's 5.95 pounds.
Sure. It's just algebra, right? X is equal to 5.95. So at what weight is the baby eligible for the service? At 5.95 pounds or less.
Can you go to the algebra?
That part? So I said z is equal to x minus the mean divided by the standard deviation. I'm plugging on all the numbers that I know. My z is equal to negative 1.75. X I don't know. My mean is what? 7. My standard deviation is 0.6. Now it's just algebra solving for x. And I get 5.95. Okay. So this part, if your algebra is bad, this part might be tough for you, but we gotta get used to it. All right, is this okay? I'm gonna just slide this in. Okay, so I'm going to just put a couple questions up here, and this, I hope, helps us understand the difference between what we're doing, okay? I'm going to say, what is the area to the left, and all of these come directly from the table, okay? All of these answers you can find directly in the table. What is the area to the left when z equals 0.30? And I'm going to say, what z gives me an area of 0.30 to the left? Okay, go ahead. You just look in your z. Don't shout out the answer. Just look in your z table or your normal table to get these answers. You don't have to do any calculations. They're just straight up in the z table, and write these down. And we'll just make sure that we understand how to use the z table. No, no. these answers come straight from the table. Okay, do you have a question or you have the answer?
No, I was just, I have a question.
Yeah, okay.
What would you do this in an exam?
Yeah, well, I will provide a copy of this table for you on the exam next week, okay? I don't expect you to memorize this week. But you have to know how to use this. Okay, do we have our answers?
Yeah.
Yeah.
Who doesn't have our answers yet? Okay. Are you struggling with the first or the second or?
Second.
No? Okay, what is the area to the left when z equals 0.30? The answer, 0.6179. Huh? Is that no good?
No, that's good.
This is the answer.
That's what I got.
This is the answer, okay? Alright, who's not getting this answer? Okay, what's going wrong? What did you get?
I looked at 3.0, I looked directly
Okay,
next to it.
so the number is not 3.0.
0, I can't find .330 anywhere.
The number is 0.30, right?
Point
right
30,
here.
point
Zero point-
anywhere. .03 I find.
Huh?
The other side.
The other
So,
side.
so
3.0.
to get 0.30, I'm gonna look up 0.3 and 0.00.
Next to
0.6179, okay? This is,
He showed me.
okay. So this is our answer here, 0.6179. Okay, so we have to be comfortable with decimals and recognize that 0.30 is the same as 0.300, okay? 0.30? Alright, and what is the z that gives me 0.30 to the left?
Negative 1.8.
This is z is equal to negative 0.52.
I'm right.
How do you get that?
How did I get that? Huh? Okay, so how did I get that? What z gives me an area of 0.30 to the left? So I go to the z table, and I'm looking for the closest thing to 0.30 that I can find. And the closest thing I can find is 0.3015. And that lines up to the row negative 0.5 and the column 0.02.
Yeah, alright.
Is that okay?
No.
Z equals negative 0.52.
Yeah.
These are the correct answers. I'm just telling you, okay? So if you're not getting these, should we try another one then?
Yes.
Okay. All right. We're taking a little bit too much time on this, okay?
But that's 2, why do we go to 2? 0.02 versus 0.30?
Huh? I'm sorry. What do we?
Okay, on your,
So what?
at the top, it says 0.02, right?
Uh-huh.
And then you came down
Uh-huh.
to 0.30, then you got, 0.3051. So why did you use, the column in 0.02 versus?
You find that after you find the point.
Okay. So I'm looking in the area. These are breaking my heart here. I'm looking for the area that's closest to 0.30. Okay. I'm trying. I want you guys all to understand. Okay.
Oh.
So the area that's closest to 0.30. We don't find 0.30 exactly in this table.
Right.
The number that's closest to it is 0.3015. That's the number I can find that's closest to 0.30 that I can get. That's provided in the table. And that number is at the row z equals negative 0.5 and the column 0.02. Okay.
So you still have to look for it.
I'm starting to get a little bit worried. Okay.
Push it back.
Huh?
Push the midterm back. Yeah.
No, I mean I can't. All right, I have a job to do, and I want you guys to learn, and I can't help but feel like some of you just don't have the preparation to be in this class, and we're slowing things down a little bit, okay? Yes.
I think maybe what's confusing is like the simplicity of just looking for the closest thing, and people think like there might be like a formula to get to it.
No, there's not.
I know.
I'm just trying to tell you everything's so easy, right? You
I
just
know.
look for a number in the table, and yeah, I don't know why everybody's like, oh, I want this formula that's magic. Okay, it's not. There's no magic formula. Let's just look for a number in the table, and I don't know.
I don't
Okay.
think it's a formula.
Huh?
I was looking specifically for 0.30. I
Yeah.
couldn't expand my brain to think it's 0.3015.
Okay,
because
that's the
not
closest
exact
number that we can get.
number.
Yeah, I know. Okay.
That's what's confusing.
All right, we'll try this one more time. Okay. All right. What z gives me an area to the left of 0.83, and what proportion is to the left of z equals 0.83? Okay.
Ready.
No?
Yeah.
All right. So what is the number that's going to give us the number closest? What z gives me an area to the left of 0.83?
0.95.
The answer I'm getting is z equals 0.95. 0.95. Okay. 0.96 is acceptable, but 0.95 is closer. Okay.
Oh.
Is that all right? Okay. No?
Well,
Yes.
you just said explain why that was.
What? Okay, if you do 0.83 minus the number for 0.95, 0.8289, and 0.83 minus 0.8315, the number that's further away is 0.96, and the one that's closer is the one that's 4.95. Okay. I'm looking around, and I know some of you guys totally have it, and I'm sorry that we're not able to progress any faster. And to the rest of you who are struggling, okay, I just have to say this is just decimal stuff. Okay, I don't know. You know, it's we're just looking for numbers in a table that are decimals, and I know some people have trouble with decimals, but you need to have a good grasp of decimals before entering this class. Okay. All right, and what's the answer to this one? 0.7967. Okay. 0.7967. Okay. There's another topic I've got to cover, and so I wish we didn't have to spend as much time as we did on this. Okay. I'm gonna have to say, do your homework this week and just pay attention, you know, try things out, make sure you understand, watch the videos if you need help, okay, and learn this stuff, okay. I would like to have done a few more examples, but I think I'm going to just have to say you're going to have to study on your own with the homework and the videos that I provided, okay. Okay, so this last part is on the binomial distribution. Let me just pass out some of these. Here, take one and pass them around, starting in the back, starting right there, and then take one and pass them down, and then move forward. And I hope we'll have a bunch of leftovers somewhere in the middle, but that's okay. Okay. Well, these guys need some, but okay. All right. So while those are going around, let me just talk about the binomial distribution. Okay. The binomial distributions for a specific random is another random variable. Okay. And the questions this answers is, if I flip a coin, let's say 10 times, what's the probability that the coin lands on heads 5 times? Okay, that's not the answer, but everybody got one of these tables? Is that good? Okay. So if I flip a coin 10 times, what's the probability that it lands on heads 5 times? Does this question even make sense?
Yeah.
Okay. When you flip a coin 10 times, how many heads might you see?
We would theoretically expect 5.
Okay, you might expect 5, but can you see 6 heads?
Yes.
Sure. Can you see 7 heads?
Yes.
8 heads?
Yes.
9 heads?
Yes.
10 heads?
Yes.
Okay, any of those outcomes are possible, right? Which one is the most likely outcome? 5 heads, right? Okay, but I might see 6 heads, okay? And that would be just as common as seeing 4 heads, right? And I might see 10 heads, but that seems pretty rare. But equally unlikely would be seeing 0 heads, right? So I'm expecting 5 heads to be the most common thing, but it's not going to happen all the time, right? If everybody took out a coin right now and I said flip a coin 10 times on your desk right now and count how many times you get heads, some of you will get 5 heads, some of you won't. Some of you will get 6 heads, others of you might get 3 heads, others of you might get 4 heads, okay? What percentage of you do you think will get exactly 5 heads?
40.
Okay.
40.
Okay, so we're making up some numbers in our brain.
Isn't that what we're doing, random numbers?
Yeah, okay. So this is how we answer it, okay? We have the binomial distribution. There's a formula that we can use, but I'm not going to teach you the formula. I'm just going to say we're going to use this table because it's easier, because the formula is complicated and you guys will complain to me. All right. In this case, how many times am I flipping the coin?
10.
10, okay? So the number of times I flip the coin is 10, okay? Anytime I flip the coin, what's the probability that it lands on heads? 0.5, okay? So I flip the coin 10 times. Okay? Each coin flip has probability of 0.5 landing on heads, okay? This is probability that one coin flip lands heads. Okay, that's P equals 0.5. And how many heads am I looking for? I'm looking for exactly 5 5 heads. This is the probability that the coin lands heads exactly 5 times. Okay, so I have n, p, x. N is 10, p is 0.5, and x is 5. Alright, is that okay with everyone? All I've done is assign letters and numbers to what this question is asking. So what I'm going to do is I'm going to look at my binomial probabilities table, and you'll notice that the first column is n, and it starts off going 2, 3, 4, 5, 6, 7, 8, and you got to flip it over, and you go to n equals 10. Okay, so it's on page A5, and it's this second chunk right here, for n is equal to 10. So I get n equals 10. And now I'm going to the row x equals 5, okay? So in your table, it looks something like this. I'm going to look for, in the column n is 10, and start there, x starts off at 0, and it goes 1, 2, 3, and I'm going to go to x 5, all right? So it's about a third of the way down on the page, okay? And then I'm going to go to the column where p is equal to 0.50. Is that good? And what is the number there? 0.246. Okay? So if I flip a coin 10 times, what's the probability that it lands on heads 5 times? 0.246. About a fourth of the time. About 25%. The answer here is 0.246. Okay? Is that good? All right. If I flip a coin 4 times, what is the probability it lands on heads 0 times? Can you answer that? Using the binomial table? Yeah, okay.
How did you get P for the first problem?
If I flip a coin, what's the probability that it's going to land on heads? 0.5. That's one we get. Okay, so for this second problem, if I flip a coin 4 times, what's the probability that it lands on heads 0 times? What's my n?
4.
N is 4. What's my p? 0.5. And what is x? X is equal to 0. Okay, so what's my answer there? 0.062. So my answer is 0.062. So n is 4, x is 0, p is 0.5, and I get 0.062. Is that all right? Good. This binomial probability thing, it applies to any situation. Okay, coin flips is the most classic example, but it applies to any situation where you're going to repeat something several times, and the probability is remains the same. Okay, so let's say 10% of people are left-handed. It's a little bit higher than that, but let's just say 10% of people are left-handed. Okay. Okay. If I have a random group of 6 people, okay, if I select 6 random people, what is the probability that exactly one person is left-handed? Alright. Can you guys see how this is also like a binomial problem?
Yeah.
Okay? Because here I'm selecting 6 people at random, the probability that any one of them is left-handed is 10%. And I'm asking, what's the probability that exactly one person is left-handed? Okay, and in this situation, what is my n? N is 6. What's my p? 0.10, okay? 10% chance that any one, if I select one person, there's a 10% chance that he or she is left-handed. And what is my x?
1.
X is equal to 1. So what's my answer here?
0.354.
My answer is 0.354. Okay, about a 35% chance that exactly one person is left-handed. Yes. Yeah, these are all percentages, okay? Everything in here is a percentage or a probability. Is that all right?
Yeah.
Okay. If I select 6 random people, what's the probability that that at most one person is left-handed? I'm changing this up. Okay. You might have to rewrite this in your notes. So what does it mean that at most one person is left-handed?
Maybe not even 1.
No? So what's the probability that at most one person is left-handed? That means either 0 people are left-handed or 1 person is left-handed, right? If 2 people are left-handed, I have more than 1 left-handed person. Does this make sense? At most 1? Are we okay with that language? So this at most 1 means 0 or 1. Okay? So what's the probability that 0 people are left-handed?
0.5.
Yeah, 0.531. Okay? So for x equals 0, the probability is equal to 0.531. You guys see that?
Yes.
Okay, and for x equals 1, what was our answer?
0.354.
The probability is 0.354. Okay? So what's the total probability that at most one person is left-handed? 0.885. I add these two together. I add them because it's an OR question, and there's no overlap to subtract out. So I just add these two together, and I get 0.885. Okay, so the probability that at most one person is left-handed, this is the probability of 0 or 1, and that's equal to 0.885. I looked up n equals 6, x equals 0, and p equals 0.1.
That's 0.9.
One more time. What's
N is 6, x is 0, so all of these n is 6, and p is 0.1. Is that okay? So probability of at most 1 is 0.885.
I have 0.94.
No, it's right here. Not 0.1.
Okay. 10%, not 1%. 10% are left-handed. Is that okay?
Yeah.
Yeah.
Okay, let's say there's a okay, a wheel, and this is win, lose, 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 lose. Okay, what's the probability of winning? This is all the pie pieces are equal.
1/5.
Yeah, so the probability of winning is equal to 0.2. Okay, that's the probability of winning. Alright, so let's say you play this game 8 times. Okay. What is the probability you win 0 times? Yeah, so I have n is equal to 8, x is equal to 0, and p equal to 0.2. So the answer, 0.168. Great. All right. What is the probability I win at least once? Okay, again, I played 8 times.
36.
No, at least once. At least once. What does that mean?
Not more than one.
One or more?
Yeah, 1 or more.
Oh, 0 plus.
So I gotta do. There's a couple ways I can do this. So I can do so all of these, n is equal to 8 and p is equal to 0.2, and I can do x equals 1, x equals 2, x equals 3, all the way up to x equals 8. Okay, and that would be a whole bunch of numbers to add. That feels like a lot of work. What's the other way I can do this? Yeah, 1 minus 0.168, right? Because if the only time I'm not going to win at least once is if I win 0 times. So winning at least once, I'm going to do 1 minus winning 0 times, and I get 0.832. Is this okay?
Yeah.
Binomial probability and stuff. Okay, so this has been easy because you know all of these problems have been binomial. Okay, the hard part is if I don't tell you this is a binomial problem, can you identify that it's a binomial problem?
No.
Maybe, maybe not. Okay.
Would it have numbers and?
Yeah, all of these things would have numbers.
No,
You're right.
I'm saying how this gives you like infinite number of things. As for when we.
Yeah, exactly. I mean, all of these things say you're going to basically you're looking for you're going to do something this many times, or you're going to it could be you're going to select 6 random people, which in other words is you're going to select a random person 6 times. Okay, you're going to pick a random person 6 different times. So you're looking for repeat some event some random trial n times. Okay. This goes under the heading, how do we know it's binomial? Okay. How do we know it's binomial? You're going to repeat some trial n times. Okay. And the probability of a quote-unquote success, okay, whether that is the coin lands heads, or you win the game, or the person is left-handed, or whatever, okay? It's an arbitrary label success, just because we don't have, I guess we could just say the probability of a something, okay, of a success for one trial is P, okay? And we are looking for, we want to know the probability of X successes. Okay, these are a little bit different from other probability questions, or I might say, you know, I pick, let's say, 30% of cars. Okay, so this is binomial, right? And then on the other hand, we have just probability rules. Okay, let's see if we can do this. Let's say we can, if I pick a car at random, the probability that it's a red car is 0.2. Probability it's a silver car is 0.5, and probability that it's some other color, we'll say is 0.3. Okay. I pick, what is the probability that a car I pick is not red? Yeah, the answer there is 0.8. Is
So
that
you
good?
didn't like repeat anything in this one?
Yeah, I haven't repeated anything here. Okay. Let's say, what is the probability that the first car is red? First car I pick is red, and the second car I pick is silver. So I have to do the probability that the first car is red, and then the probability that the second car is silver is, no. So it's going to be probability that the first car is red is 0.2, and then I have to multiply it, right? The next probability that the next car is silver is 0.5, 0.1. Okay? And so these are your probability rules, and don't get them mixed up from a binomial situation here. Okay? We have a couple of minutes left, so maybe I'll go back and we'll try another or an example, and let's see if you guys can just figure it out. Alright, I'll say height of men follows normal distribution. The mean is equal to 70, and the standard deviation is equal to 3.1. Alright, I'm going to say what percent of men are shorter than 5'8", so 68 inches. And I'm going to say, how tall is a man in the 90th percentile? Okay, so this means the man is taller than 90% of all other men. Of all men. these are your answers here. I will show you how to get the answers right now, quickly, okay? What percentage of men are shorter than 68 inches? Here, my mean is at 70, and I'm drawing a line at 68, and I want to know what is the area to the left of 68. So my z is equal to 68 minus 70 divided by 3.1, and I get negative 0.65, is that right?
Yep.
Okay, so z is equal to negative 0.65, and the area to the left of z equals negative 0.65 is 0.2578. Here's our answer. How tall is a man in the 90th percentile? Meaning the man is taller than 90% of all men. So here is 70, and now I'm drawing a line where I'm going to get 0.90 to the left, 90% to the left, 10% taller. Okay? The z that gives me 0.90. So z that gives 0.90, okay, actually 0.8997, which is the closest number to 0.90, is z equals 1.28. And so using z equals 1.28, z equals x minus mean over standard deviation, I'm going to have 1.28 is equal to x minus 70 over 3.1. Solve for x, I get x equals 73.97. Okay, be sure to review those problems and understand them. And good luck as you guys study for the quiz, or midterm exam next week.